transport layer. Exactly what is happening in the transport layer. Mobile stations offer services like email, web browsing, and many other services. Mobile stations, while roaming from home network to target network, mobile stations offer services like email, web browsing, and many other services. Today we discuss about transport layer particularly. What is happening in the transport layer, how ports are working, what are the kind of transport protocols we have in transport layer. These all we will discuss today. And is it audible to you clear, my voice and video? My voice and video clear to you? Okay, okay, fine, fine. And today we will discuss concepts like TCP network protocol header, means TCP protocol header, UDP protocol header, and UDP data transmission, how it works, TCP data streams, how it works, and TCP connection states, TCP packet delivery, way of packet delivery, and control. In transport layer, how exactly flow control we are managing, congestion control, and what are the problems we are facing with TCP in a network with the mobile nodes, and some modifications. So modifications made in a TCP for use in a wireless mobile networking by splitting TCP and indirect TCP, mobile TCP methods. These methods we will discuss in next session, up to flow control, transmission control, and conjunction control. Up to this we will discuss today. We know about mobile stations, how exactly mobile stations architecture, mobile IP networking architecture present in the real-time environment and all. Mobile stations offer services like email, web browsing, and many other kind of data services utilization. Today we discuss about the purely about the transport layer. The main functions of the transport layer is sequential transfer of data. The main functionality, if we consider transport layer, the main functionality is sequential packets of transmission of data. We will discuss about the port and TCP network, TCP protocol header, TCP connection states, and packet delivery now. And if we just consider first of all port, what is this port? In a computer and telecommunications devices, a port generally specific place for being to some other device, usually a socket. It's a place to connect with the other communication devices with the physical connection by using the socket. A network port is a process specific or we can say it's an application specific software construct. It's a software construct only, that port, and it serving as a communication endpoint. It's serving as a communication endpoint, which is used by the UDP, TCP, and other examples of layer protocols. A specific network port is identified by its number, commonly referred to as a port number, the IP address in which the port is associated of transport protocol used for the communication. Here, main thing, if we consider specific network port is identified by always its port number only. We can commonly call it as a port number. The IP address in which the port is associated with the type of transport protocol used for the communication, and this IP address will bind with particular port number for the communication. trans protocol used for the communication. Here we are mainly discussing the communication. A port number is a 16-bit number that ranges from 0 to 65535. A port number is a 16-bit integer number that ranges from 0 to 65535. And if we see the extra points about the port, how exactly it's working and all, a socket provides an interface to send to and from the network through a port. The packets always are communicating through port only. Socket provides an interface to send and receive the packets from network through a port. Port numbers can be well-known and dynamic or private port numbers. You can call it as a. If we take well-known ports, that range is 0 to 1020. If we take dynamic or private ports, that range is to 65535. And clients usually use dynamic ports assigned by kernel at runtime. In real time, if we take clients automatically while sending and transmission, this client usually use dynamic ports only assigned by kernel at runtime. Kernel means internal OS will be allocate that port number dynamically. And next, if we consider, and it's a port number is a 16-bit number that ranges from 0 to 65535. And if we take well-known port, that's a range from 0 to 1023. If it is a dynamic or private port, it's a range from 1024 to 65535. Okay. Now we will discuss about the transport layer. After that, we will discuss about the UDP and TCP. First, we will work this transport layer and all. We know this OSS standard. If we consider OSS standard, this transport layer is fourth layer in the OSS standard. It transport layer provides transparent transfer of data. Transport layer provides transfer of data between end systems using the services of the network layer, packets between two communication systems. Transport In transport layer level, the ports will work. Network layer level, IP will work. With the help of network layer, transport layer will always try to send and receive the packets. Transport services perform peer-to-peer communication. The data communicated by the transport layer is encapsulated at the transmission side and decapsulated at receiving side. Only P-transport entities actually communicate using the PDUs of the transport protocols. Only that particular peer entities can decapsulate that particular packet and be able to see the content of the packet. It's a peer-to-peer communication in transport layer with the help of port numbers exactly working. And the transport layer stages, it is the responsible it is to receive the message at receive acknowledgement from the receiving end to transmitting side. We can say it's a reliable arrival of message and provides error checking mechanisms. And any error checking mechanisms also happen in transport layer. And data flow control means number of streams. If we say example HTTP also is there, how many number of streams should be used, how many number of clients maximum we can support with the help of server, this kind of all this stuff work with the transport layer. The transport layer provides services for connection mode. We have two types of sockets like stream oriented stream oriented sockets. We can consider this one as a oriented sockets. And next socket type is data socket, means connection less oriented, connection less oriented, connection oriented and connection less oriented of sockets we have. If we take stream socket, it's a connection oriented and reliable delivery is there. And in order of packets is guaranteed. It's a bidirectional. We can say examples for this TCP protocol, SCTP protocol. If anything happens in packet delivery, error will occur. Means that packet error will recover and the exact data transmission will happen in TCP and SCTP kind of transport protocols. If we take datagram socket, it's a unidirectional delivery. In this, we can say no is not guaranteed. Connection does not exist. Application indicates destination each packet. Initially itself for a server and client connection won't exist. That OS internally that OS only will give for each packet the destination IP address. Can send and receive. It's a bidirectional thing. Means, but unreliable delivery is there. Unreliable delivery. Anything happen in packet delivery, error does not show. That is the difference between stream socket communication, data gram socket communication in transport layer level. And the transport layer controls the reliability of communication through flow control, segmentation, and error control. We will discuss about the flow control and all these mechanisms also. And two great examples of transport protocols are TCP and UDP. TCP and UDP wise we will discuss now. OSI layers. In L4 only, this one we are using this TCP or UDP protocol. This is a headers, first encapsulation and receiving side decapsulation of the header. Those processes are happening. It's a transmission system, it's a receiving system. First, we will discuss about the UDP protocol. Okay. We have mainly two main protocols for transport layer, TCP and UDP. If we take user datagram protocol, the user datagram protocol, the UDP is a connectionless protocol. There is no session establishment, data flow and congestion control and session termination in UDP. These kind of things won't happen in UDP. It transmits like a person using a phone who just speaks without waiting, irrespective of whether the receiver at the other end is listening or not, replying or not. That like in phone call, the other person is replying or not. Is like our phone call. We can say is a good example for UDP. Like just we are speaking whether that receiver person is receiving or replying, it won't bother. Transfer side won't bother. Just it will speak, reach it or not. This transmission side won't bother anything. And port is a service access point. We can say a software service access point for data input and output through which a service is identified by the socket. And we can say UDP UDP ports binds with the IP for packet delivery and receiving. We know about the UDP header. The UDP header is used at the for sending and receiving the packets. If we take the UDP header, there contain like source port, destination port, and that UDP packet length, UDP packet checksum. Checksum is for error checking. The chat members. The chat members chapter. If you want to post the chat. Okay, I will try slide searching. Oh, okay. Okay. Uh, UDP source port, destination port, and UDP packet length, that length, and some checksum used for error checking of the packet, whether the transmission side and the receiving side correct packet is receiving or not. That purpose checksum is we are using. And if we go with the client and server at first, uh, at first that connection won't be. Whenever packets is sending from transmitter to receiver, that application won't will assign that IP address for UDP socket programming, UDP socket communication, and it will try to give the packets to the receiving end. Always is like this only. UDP socket programming is a unreliable delivery. Anything happen in packet delivery, error does not show. No order guarantee, and that packets orderly receiving or not, the UDP won't bother. It's a and connection does not exist. Application indicates destination for each packet and can send and receive bidirectional communication, only UDP communication. It's all in a UDP communication. Next, we will see about the TCP protocol. TCP protocol is a connection-oriented protocol. Means connection-oriented means initially itself for client and server this connection by using the three-way handshaking mechanism. If anything happens in packet delivery, error will occur. That's a connection-oriented and reliable delivery is present in the TCP protocol. A transport and next is it's a connection-oriented session will be established, data flow and congestion control and session termination in TCP. Everything will be happening. What is congestion control and session termination? Exactly what is happening? What are the steps present in the TCP? We will see now. And this is we discussed about the user data functions of this one. UDP this we have discussed, and UDP header fields contains mainly four fields: source port and destination port, and that length, packet length, and checksum. These four fields will present. It's all about the UDP header, transmission of data stream. Okay. What is exactly happening in the transmission of TCP protocol? Now we will see. Uh, while transmitting the TCP packets, it's encoded data from the application layer. Application layer will be protocol header words. It will encode and header will add to the packet. At the receiving end, the reverse process of the decoding at each layer to retrieve back to application data takes place. This is exactly happening in UDP and TCP protocol. And what is happening exactly in transmission of means TCP transmission as data streams. We know TCP is a connection oriented protocol. TCP is a transport layer protocol for the internet. The main feature of TCP, if we discuss, and how exactly this transmission happens as a data streams in the internet, we will see. A segment is transmitted as a data stream of bytes, also known as the packets. Its segmentation is performing in the transport layer. That one we are calling it as everything in this transmission is calling in transport layer as a packets. With the help of I2 protocol, it will work. And this TCP transmission is like a streams, indicates that transmitted sequentially and are received by transport layer at the other end in the same sequence as they are sent. As they are sent. See, here byte by byte transmission will happen in TCP. A set of 32 bits of a word has four sequences. The application layer data is transmitted and received as a stream consisting of a sequences. Everything is sequences here. The receiving and also whatever the transmission has sent in sequence delivery only it has to receive. The TCP header includes the sequence number of the first byte to be transmitted through the stream. If we take TCP header exactly, what are the fields present in TCP header? Source port and destination port. Source port will occupy 2 bytes, destination port will occupy 2 bytes, and TCP header. And 1 byte will occupy offset value and reserved for 1 byte, next 1 byte. After that, we have TCP flags like CEUAP or SF. Exactly, we will discuss about all the functionalities of these flags. And window size, it will maintain 2 bytes and checksum 2 bytes urgent pointer. Urgent pointer is 2 bytes. TCP options, variable length optional. Next 4 bytes, it will have a TCP optional fields like variable length and optional. These things. It's a 20 byte header. TCP header is a 20 byte header, and this TCP header includes the sequence number of the first byte to be transmitted to the through the stream. And we have one advantage in TCP, that is buffering and retransmission. Up to get acknowledgement from the receiving end, it will buffer the packet. If it won't get within time that retransmit that acknowledgement, it will try to retransmission. Means buffering and retransmission is the functionality of TCP. The TCP transmitter buffers the segments to receiver acknowledges a data sequence. The transmitter empties the acknowledged bytes from the buffer. It retransmits from the byte next to the data sequence number of the last successfully transmitted. It also retransmits in case no acknowledgement is received within a timeout period. It's a fair advantage of buffering. It's a fair advantage of TCP protocol. And one more advantage we are getting from TCP is session start, data transfer, and session finish fully acknowledged and end to end. Uh, Session start at the time of session starting, that is acknowledged, and data transmission is always acknowledged, data finishing fully acknowledged end to end. Handshaking of packets is used for acknowledgement and all transactions are acknowledged in the TCP protocol. In order delivery is a uh, one of TCP. The TCP transport layer delivers the segments in a sequential order. Particularly, if we take example, when the nth segment has been delivered, only then is the n plus one delivered to the application layer, and before that, like nth segment has been delivered, then n plus one, that number will get as the acknowledgement number. And conjunction control and avoidance. This is also one of important feature in the TCP. Means lack of acknowledgement within the timeout period in a step or receive of duplicate acknowledgement signals conjunction. In this case, one method of controlling conjunction is to gradually increase exponentially the number of bytes in the stream in successive steps. Means sometimes it happen like duplicate acknowledgements, and in this case some conjunction will happen. Here it's have its own mechanisms to overcome this conjunction. The number of transmitted bytes in a step is reduced to off on encoding convention. It's always happen in the TCP protocol. And receiving of data streams. This particular signals received by the transport layer at receiving end in the same sequence what transmitter has delivered. Means we know in that header that sequence number will be present. TCP header includes of sequence number. Buffering. Yeah, buffering is the advantage here. Buffering and retransmit. TCP transmit buffers the segments. The receiver acknowledges the data sequence. The transmitter empties the acknowledged bytes from a buffer. It retransmits from the byte next to the data sequence number of the last successfully transmitted byte, and retransmit in case no acknowledgement is received within a timeout period. It's a buffering and retransmissibility of TCP. Retransmission in fully acknowledged end to end. Means in TCP everything that connection and packets transmission, everything, and while termination of the connection also everything is fully acknowledged. In order delivery, we have discussed in order delivery is the main functionality, one of main functionality. The TCP transport layer delivers the segments in a sequential order only, and receiving side also exactly sequential order only it will receive. Conjunction control means sometimes duplication acknowledgements, duplication packets will receive at this time with respect to streams. We have it have its own mechanisms to overcome this conjunction. That's a conjunction control mechanisms. Number of methods we have to control the conjunction. Here one step is like a method of controlling conjunction, the conjunction. Anyway, we'll see exactly what is how to overcome this conjunction. TCP header we have discussed. It's a 20 byte header, and first 2 bytes are occupied with the source port, next 2 bytes are occupied with the destination port, and 4 bytes are occupied with the sequence number. Now 8 bytes completed, and the next 4 bytes acknowledgement number. Now 12 bytes completed. Offset 1 byte, reserved 1 byte, and TCP flags 2 bytes. Now 14 bytes. Now 14 bytes completed. Next to 2 bytes window size. Now 16 bytes completed. Now up to 14 bytes completed. 16 to 20th byte, this is checksum and combination of urgent pointer. That's it. Up to 16 completed. 16 bytes to 20th byte. It's a TCP option, means variable length optional fields we can use here. It's a 20 byte header TCP. These are all
flags here we given FSRPAU. The window size field specifies the number of bytes the sender is willing to receive from the acknowledgement field value. The window size field specifies the number of bytes the sender is willing to receive starting from the acknowledgement field value. It's all about TCP header urgent field. Okay, we'll discuss about the TCP header. The reserved bits facilitate the addition of more flag bits or provide a provision for extension of present functions. And checksum of the header and the data and the next bits. This urgent field is it's a communication offset value to be added to get a sequence number from the sequence number of the present segment. Then the value points to the sequence number of the octets following the urgent data. Means urgent data is urgent data is nothing but next immediate transmission data. 1 minute, I will check. Is it okay now, PPT? Are you able to see? Are you able to see PPT? Okay. If we take mainly flags in TCP header, it's a control bits and U flag, that's a urgent flag. Is set means urgent pointer field is being used for control of flow. That is the purpose of this U field. And A, acknowledgement purpose. Is set means acknowledgement number what field has significance and can be used to control flow and conjunction. That is the thing. And P is set means push the data. R means is set means reset the connection. S means this is sync. Sync is set means synchronize the synchronize the sequence number. F means is set means data is finished. No more data for sending at present. That is the importance of flags present in the TCP header. Okay, we will see PPT. This is purely about the TCP data streams and data delivery. Okay, we will see about the TCP data streams. TCP provides the delivery mechanisms for the data streams. It's a have its own delivery mechanism for data streams. Each stream consists of bytes. It's a byte-oriented transmission. Data streams are delivered using a virtual connection between sockets. Between sockets, virtual connection, and this data streams communication is happening. Each socket has its own port number and an IP address for rendering services to an application. Means whatever the
received at receiving end to give application. It has its own port number and IP addresses. IP address. The number of bytes in a stream is equal to the transport protocol data units. The number of bytes in a stream is equal to the transport protocol data units. We can say this number of bytes in a stream, that bytes are equal to the transport protocol data units in a memory buffer and transmitted by a TCP protocol. A TCP segment defines the TCP data stream. Means that the transmission period depends on maximum transfer unit. Means the maximum transfer unit size. It depends on the size presence in a given network state. The protocol employs timers to synchronize the data stream between both ends. Here we are always using the RTT, round trip time is the time interval between the start of the transmission of a data stream of given TDP, this transmission PDU to the receiver layer and the receipt of acknowledgement of successful transmission. This round trip time is important in order to set the time interval during which the transmission expects the receiver to send a TCP stream with the acknowledgement. Important thing, this is a round trip time, and this is carried out so that the transmitter can transmit from the acknowledged field sequence number onwards. This is TCP data stream. Means consists of bytes. Everything is in byte transmission delivered using a virtual connection between sockets. Each socket has the port number and IP address for sending the data. Means number of bytes is equal to the transport protocol data units TPDU that are placed in a memory buffer. TCP segment defines the TPDU in a stream. PDU depends on MTU, maximum transfer unit, presentable in a given network. Means here some size is giving maximum transfer unit. Up to that size only we are able to transmit in a TCP protocol. Means it's always using timers while transmission or receiving end. Some timers are there, mechanism for data streams. And RTT, this is round trip time we will use in the TCP data streams. The time interval between the start of the transmission to the receiver layer and receiving acknowledgement of the successful transmission. It's a round trip time. Means transmitting of the packet and receiving of the acknowledgement. This is, we call it as a round trip time. To set the time interval during the transmitter expects the receiver to send a TCP stream with the acknowledgement field set to indicate the successful set bytes. Means it's a main intention to set this round trip time is whether packet is received, packets are received and receiving it properly or not with the help of acknowledgements to know within this round trip time. That is the intention of this round trip time. Okay, now we will discuss about the TCP data delivery. How exactly is it delivering the packets? The TCP is delivering data delivery. We will see now. Just we will take 5 minutes break and we will meet 10:05. Please give me 5 minutes break. Okay, fine. Now we'll discuss about the data delivery. Means in TCP there is acknowledgement of sequences sent from one end to the other. Means whenever receiver the packets, it's always acknowledged by the receiver. Acknowledgement field specifies the sequenced byte number from which the receiver end expects the sender end to transmit in the next sequence. Exactly, if for example it received the 1000 number, it acknowledgements with the 1001, means that the receiver is expecting the 1001 sequence number packet. Like this acknowledgement will happen in the TCP data delivery that do not reach the receiver successfully within a timeout period or retransmitted. With that acknowledgement, uh, transmitter comes to know that some bytes are not received at the receiving end. It will try to retransmit the packet. The checksum field detects errors. It's always detecting the errors checksum. The fields takes into account the header as well as the data. Header as well as the data. With respect to that, the checksum will be works. The receiver discards any erroneous packets in a data stream. Let us assume that one scenario, like after sending an acknowledgement, a receiver gets the packets in the stream which were delayed and acknowledges these two. But in this intermediate time, the transmitter retransmission as per the previous acknowledgement, and thus the retransmitter retransmitted the delayed packets. In such cases, the receiver discards the duplicate packets. Retransmissions in the case of no acknowledgement ensures reliable, guarantee, and error-free data transfer. Means its main agenda is to ensure reliable, guarantee, and error-free data transmission. In this case, it will just discard the duplicate packets. No retransmission and no transmission mechanism similar to the transparent and non-transparent in this mechanism. Here, while connection establishment time, we have like 4 pages. Listen, synchronization sent, synchronization received, establishment. 4 messages will be used. And data of application layer octets are transferred after establishing the connection. Always octets, these bytes will be transmitted once connection is established, and the connection finish and then close. Finally, while finishing the connection, finish and close messages will be used. First, we will see about the listen, how listen will work. Means TCP receiver is waiting for listening to a connection request from the transmitter. If we see client server communication, first client will give the request for connection. Server side, what it will do, server process the request. Based on resources, it will try to allocate the connection to the client. Server sends response to the client, whether a rejection or a selection. Based on that, client handles the response. Server and client exchange messages over the network through a common socket API. Common socket API only, it will messages will be happen. This is the process while establishing the connection. It's a checksum field and TCP data delivery the data. First message is listen. First message is listen. TCP receiver end is waiting for listening to a connection request from the transmitter. In the transport layer level, it will work. And next is SY and send. This sync, a sync data stream sent by the trans with the flag set with the S flag set to 1 and waiting for the receiver data stream with sync and acknowledgement. Then sync received. A sync acknowledgement sent by the receiver data stream means that receiver end will send. TCP transmitter side will receive. Yes, A flags will be set, and TCP uses the acknowledgement field at the packet and sends an acknowledgement to the TCP. For example, if sync sequence number sent in step like sequence number is n, then it should be acknowledged with the n plus 1. Now next message is establishment.
In establishment, what will happen? And as an transmitter transmitter data stream for TCP A2 means TCP transmitter to TCP transmit TCP transmitter to TCP receiver. It sets the acknowledgement field according to in the next data stream, and A flag is set in that. S flag is reset. This establishment means connection is establishment, like one message it will send, and now data transfer will happen. In data transfer phase, in data transfer phase, data stream always has this sequence number field for the byte starting from which the data of a segment is being transferred through the stream. Like it's a calculation, everything. What are the bytes have? Byte is starting that will send as a sequence number here. And finally, wait there with F log finished. Set to 1 and accepts fin acknowledge and final state wait. These all messages are happening at the time of closing the communication. With closed, this data transmission will close. And if we see, means here an example how this segmented one is acknowledged from the receiver, this kind of stuff here, given examples. This is at the closing time. We will use the acknowledgement way, and closing this will use at the time of closing the socket. Next thing is this TCP data flow control. How we are controlling the data flow in TCP transmission. We will see that one. Protocol, whether we are using TCP, UDP, or SCP, that socket type stream oriented or and domain, whether it's a internal or outside network, it's a connection like this. With the help of these things, we will create this socket. With the help of that socket pointer, we will bind with the port number. It is used for identifying the socket. This binding, it binds the socket with a specified socket. Will happen. Listen, the server always will listen for the request from the clients. It will always listen. Just a second. Yeah, now it's okay, right? Just a second. PPT from the server, AV server, you can download, right? I don't know exactly previous one you people are download or not. Previous PPT is
Okay, I'll continue. Server wait for the listening the connection request from the clients. Whenever it listen the request from the clients, it will just give connection to particular clients. Here, number of clients it is able to accommodate the type of parameters we have. Up to certain level of parameter we can accommodate for the server. And once it says listen and it says accept the server, that connection is established with the client. And now it will accept the package from the it will try to accept the connection, and after that it will receive the package from the client, as well as it is in a position to send the package to the clients. This two-way communication is happening here. Like this only exactly, client side also, first socket will be created. It means what type of socket is required, whether it's a stream oriented or connection oriented, that type of socket with the kind of protocol, whether it's a TCP, SCTP, UDP, that all we will create the socket at the client side also, and with the help of the socket identifier, we will try to send the packets and receive the packets with respect to the server. It's always two-way communication happens here. And now we see exactly how what is happening in the TCP data flow control, how we are controlling this flow and all. Um, in data flow control, what is happening exactly? While we are transmitting the segment in the data streams, which are transmitted as a packets, a few packets of data stream may reach the other end, other end, and some other packets in the data stream will cause the error and may lost also. Means we can say that packets are not reaching at the receiving end. Byte to succeed. To succeed, lost successfully received one. A controlled data a controlled data flow is happening in the TCP data transmission. Here, what are the mechanisms we are using for the data flow control? Window size adjustment. Window size adjustment tuning. Window size is adjusted, and through this, what are the errors happening in the receiving end, and what are the packets not received at the receiving side. By those estimation, with the help of acknowledgements, we will try to adjust the window, and we will transmit the segments. This is one thing. And for set of segments cumulatively, we will acknowledge the we will send the acknowledgement. This one we can call it as a cumulative acknowledgement. This is one advantage we have in TCP data flow control. We always try to give the acknowledgement to the transmitted packet, whether those packets received or not, or errors are occurred. Those kind of things will happen in the cumulative acknowledgement. And reverse packet acknowledgement. It's a reverse packet from the receiver piggybacks the acknowledgement. This is a reverse packet acknowledgement. Reverse receiver to the acknowledgement. Duplicate acknowledgement means already acknowledged, and again we are acknowledgement. That time this transmitter will just discard that duplicate acknowledgement. And delayed acknowledgement. If delayed acknowledgement also, that won't helpful at the transmitters. They're all mechanisms we have at transmitting and receiving side TCP data flow control. Till now we have discussed about how transport, what is transport layer, and how UDP protocol, how UDP protocol with the help of header it works, and TCP protocol with the help of header, what are the features it present, and data flow control of TCP, and TCP data streams, TCP data delivery, these kind of stuff we have discussed. Convention in our TCP. In next session, we will discuss about that one. Till now, any questions? My session is ending with this. Tomorrow we will discuss with the next convention in TCP and the next other topics and all. Any questions up to this? Okay, thank you for all. I'm concluding this session. Thank you so much.